From our example, we had seen that we can solve an algebraic equation for a different letter by plugging in guess numbers through trial and error. For example, in our example, we had first tried 20 to see if we could get close to a 1-inch deflection, and we got 1.8. So we went to a higher number of 30, and we got 1.2. And then we went to 40, and we got 0.9. And then finally 36, which brought us closer. But those were only approximate answers. They weren't exact answers. So how can we solve for the exact moment of inertia, I, to get a 1-inch deflection? So the answer to that question is we have to unwrap the present. And in this case, our present is the moment of inertia. Our present is I, and we want to get I by itself. We want to get I to a point where we have an equation where we have I equals something. That's what we want to get to. And we can get to that by manipulating the algebraic equations. Now, every algebraic equation is like a scale. Okay? We had talked about this previously, that the algebraic equations, they are like scales, where on the left side we have something, and on the right side we have something, and right in the middle, in order to balance out the scales, both sides need to be equal. So we could have a mystery number on this side, and then 12 on this side. If the scale is balanced, then we know that our mystery on the left side is indeed 12. So, because every algebraic equation is like a scale, then as long as we do the same thing to both sides, for example, if I add some more mass to this side and some more mass to this side, where the masses are equal, the equation is still the same. The equation is still true. This side is still equal to this side. I can manipulate the equations like that just as long as I do the same thing to both sides. Let's see how this works out practically with our example. So we want to get I by itself. So let's try and get I by itself. So we have D equals PL to the third over 48 E and then I. What we want to do is move I to a point where it's on the left side by itself. And to do that for this equation, it looks like we just have to move I to the left side and then move D to the right side. Now, on the right side, it looks like I is being divided. So in order to get rid of it on the right side and move it to the left side, we would want to multiply by I on both sides. So we'd multiply the right side by I, and we would, sorry about that, we would multiply the left side by I. Both sides by I, so that the i's on the right side cancel out. Because if we divide by I and then multiply by I, those cancel out. And then on the left side we are multiplying by I, so we end up with I times D equals PL to the third over 48 E. So then we just have one more step to get I by itself on the left side. We need to move D to the right side now. And now D is being multiplied on the left side. So what we would want to do is divide both sides by D. That way, the D's on the left side cancel out, and that puts us with I alone on the left side, and then we have a division of d on the right side. So let's rewrite our equation now for what it would be. It would be I equals PL to the third divided by 48 ED. So here we have a situation where I is by itself. Now we can plug in the numbers to find out what the I value, what the moment of inertia would be for the values we were given. And the values we were given, let's see, we had P equals 900 right here. We had L equals 132, E equals 1,200,000 psi, and then of course D, the deflection, equals 1. So let's write all that in. So we have 900 pounds, L is 134 to the third divided by 48, 1,200,000 psi, and then our D value is 1 inch. Now we can easily plug these numbers in to get our answer. So I'll bring up my calculator, and I'll do the 134 to the third first, since that's a little bit more complicated. 134 to the third is 2,406,104 times 900 is a big number, divided by 48, divided by 1,200,000, and divided by 1 is just going to be the same thing, which looks like we have 37.595375. So let me move this over here so that I can write this 37.595375. And let me see if we were supposed to round anything. It doesn't say round, so you just leave it like this, or we see that this is closer to 37.6, and the units are inches to the fourth. So here's our answer. That process, we can solve any equation for any variable, no matter what the given information is. Just as long as we have enough information, we can solve for any variable with any equation.